So yesterday, where did we stop? We discussed what is meant by rank using determinant model. Now, any doubts in the yesterday's class, or shall I go for next model? That is using rank using echelon form. So how to find out rank of the matrix using echelon form? Why do we require this form? Because for higher order matrices, using determinant becomes difficult. Therefore, we have to find out rank using a methodology called echelon form. So using this, easily we can evaluate the rank. So what is echelon form is a matrix A is said to be in echelon form. A matrix A is said to be in echelon form if some conditions are satisfied. So echelon form if the following conditions are satisfied. First condition, 0 rows if any, 0 rows if any should be towards bottom. If any should be at the bottom of the matrix. This is must. So bottom of the matrix. So first I will explain with an example. So keep this in the mind. Whenever I'm explaining, I'll explain with an example. You can understand this easily. For example, this matrix, is it in echelon form or not? We can check. 0 rows if any. If there is no 0 row, no problem. If at all it is there, it has to be at the bottom. That is first condition. If it is here, for example, we'll apply interchange operation. We'll try to get it to the bottom. Getting to the bottom is must. Second condition is the first non-zero element. We define a word called pivot. So often we'll be using this. The first non-zero element of any row is called as pivot of that row. The first non-zero element of a row is called pivot of that row. Is called pivot, or it is also called pivot of that row, or it is also called leader or leading element of that particular row. Element of that row. So leader is defined for a pivot and leader are defined for every row. The first non-zero element of a row is called pivot or leading element of that row. For example, this is first row. In this, which all are non-zero, the first non-zero element is 1. This is called as the leader of first row. Okay. Similarly, second row. What is the leader is this. So I will change it. It need not be 1 all the time. If I take 1 here, you may think that leader should be always 1. No, it can be anything. So in the second row, the non-zero elements are 2 and 4. So this is the leading element of second row. Third row does not have any leader. So 1 and 2 are called leaders, or they are also called pivots of that particular row. So it is defined for each row. Condition is, we define a column called the column containing pivot is called pivot column. The column containing pivot is called pivot column. Pivot column. How to find pivot? The first non-zero element is called pivot. The column in which pivot is lying is called as pivot column. So for example, 1 is there. This is pivot of first row. How to find pivot? Use row to find pivot. How to get pivot column? Use column to find pivot column. Pivot is obtained from a row. The column in which it lies, this is what is called as pivot column. Next, second row. What is the leader? 2. So it is lying in which column? This is first column. This is second column. This is third column. This column is also called pivot column. So like that, how to get a pivot is, Find out the pivot using the first non-zero element. The column in which it lies is called pivot column. The condition for echelon form is, first identify the pivot column of first row corresponding to first row. All the elements below the pivot in the pivot column must be 0. In the pivot column must be 0. Above need not be 0, but below in the pivot column must be 0. So the column containing the pivot, this is the pivot 1, then this is the pivot, this is the pivot column. In this pivot column, below the pivot, everything should be 0. This is the one. In the second row, pivot is 2. Below that, it is 0. So first row, pivot is 1, lying in first column, below that 0. Second row, pivot is 2, lying in third column, below that 0. Above need not be 0, only below. Third row does not have any pivot, so you can leave it. So this is one condition for echelon form. What are the conditions? 0 row should be towards bottom. Column containing the pivot is called pivot column. Pivot is obtained from the row. For each row will have a pivot. The first non-zero element is called pivot. The column in which it lies is called pivot column. Below the pivot, in that pivot column, everything should be 0. Second row also should be same. After completing all this, one more condition is there. Leading zeros. What are leading zeros? Zeros preceding the pivot element are called leading zeros. Leading zeros. So for example, not preceding means left side. This is the pivot. Left side is called preceding. Right side is called succeeding. Left side, there are no zeros. How many zeros? Preceding zeros? No zero. So 0 zeros. For second, left side, how many zeros are there? Preceding to pivot, 2 are. Third row, we are having 4 zeros. So these zeros should be in the increasing order. As we move from top to bottom, they should be in the increasing order. So leading zeros of rows must be in increasing order. Leading zeros of rows must be in the increasing order. Okay. So as we move from top to bottom, they have to be in increasing order. Then this form is what is called echelon form. What is the advantage of this form is rank of the matrix is defined as number of non-zero rows. What is a non-zero row? This is number of non-zero rows in the echelon form. Non-zero rows in echelon form. This is what is called as rank of the matrix. What is meant by non-zero row? What is meant by zero row? All zeros. A row containing all zeros. A row containing all zeros is a zero row. What is meant by non-zero row? Non-zero row means a row which is not zero row is called non-zero row. Is called non-zero row. Or that is zero row means everything zero. Non-zero row means not all zeros. That means at least one element is non-zero. At least one element in that row is non-zero. In that row is non-zero. Okay. Then number of non-zero rows gives you what is in the echelon form, it gives you what is called rank of the matrix. For example, for this, what is the rank? This is a zero row, last one. This is non-zero row because not all zeros. Here also, not all zeros. So this is non-zero row. This is non-zero row. This is zero row. The row which is not zero row is called non-zero row. Zero row means everything zero. Here everything is not zero. So this is non-zero, this is non-zero row. Therefore, rank is 2. Rank of the matrix is 2 in the exam. So this is how we try to find out the rank of the
Once
matrix.
explain, ma'am. At least one
Yeah,
element in that row with example.
so yeah. In this example, zero row means everything zero. Zero row means everything zero. In this row, is everything zero?
No.
In this row, all are zero or no? All are not zero. If all are not zero, then it is non-zero row. Here everything is zero. So it is a zero row. Here not all zero. So it is a non-zero row. Here also not all zero. The non-zero row. So how many non-zero rows? 2 non-zero rows. That is some zeros, some non-zeros are there. It is called non-zero row. Some zero elements, some non-zero elements mixed. Then it is a non-zero row. Everything zero, then it is a zero row. In this, there are some non-zero elements. If there are some non-zero elements in a row, then it is called non-zero row. So this is non-zero row, this is non-zero row. This is zero row. How many non-zero rows? 2. So what is the rank of the matrix? 2. Is it clear? Did I answer your question,
Yes.
Emma? Yes. Okay. Let us go for now, finding rank of the matrix. So I'll try to get you the question. Find the rank of the matrix. We'll take one matrix. Let us try to find out the rank of that particular matrix. For example, rank of the matrix. Is it visible? Yeah. So rank of the matrix. We can have rectangle yesterday's problem. Very easily we can solve. 1, 2, 1, 2, 3, 1, 2, 3. For example, this is, we took rectangle, no? 4 minus 1, for example. This is the rectangular matrix. Yesterday we have seen, we struggled a lot. We found first minimum, that is 2. We found all 2 by 2 submatrices. At least one of them is non-singular. Rank is equal to that. Otherwise, less than that. Lengthy procedure. Here, easy to find rank is find out the non-zero element, 1. We have to make, this is the pivot. It is lying in which column? First column. So this column is called pivot column. In this column, below the pivot, this should be 0. Everything should be 0. This should be 0. How to make this 0? Use pivot to make this 0. You know this row is what is called first row R1. You might have studied in your intermediate. This row is what is called R2. We want to get here 0. So we apply elementary operations. So what are elementary operations? We can apply R2 minus 2R1, R3 minus 3R1 like that. So apply the
R2
operation
minus R1.
R2 minus R1 to get 0. This is called elementary operation. So if you apply that operation, as a result, which row will be affected is second row. Here 2, here also 2. Only this row will be affected. First row remains the same. R2 minus R1. 1 minus 1, 0, 0, 0, minus 5. This is leader, below that 0. Second row, this is leader, pivot. Below that, nothing to make 0. It is in echelon form. So what is the rank of the matrix? Therefore, rank of A is number of non-zero rows. How many non-zero rows?
1.
1. One or 2?
2, ma'am. 2,
2,
ma'am.
2, 2, 2.
Non-zero rows. So non-zero row means not a zero row. If everything is 0, 0 row. If everything is 0, only 0 row. Otherwise, non-zero. So this is non-zero row. Here everything is not 0. Some non-zero element is there. So zeros, non-zero. If both are there, it is non-zero row. Everything 0, 0 row. So how many non-zero rows? 2. So what is the rank of 2? So like this, easily we can find rank instead of determinant, this would be easy. I'll give you one more. Find the rank of the matrix. The rank of the matrix 1 a square a power n minus 1, 1 a square a power n minus 1, 1 a square a power n. This is an n by n matrix. Yes. Option A, n. Option B, 0. Option C, depends on A. Option D, 1. So, which option correct? Let us see. What we have to do? First, we have to identify what is your answer? Any one of you? Because some students are there who are attending repeat.
One means
D.
rank is one.
D, madam.
D is some are saying. So let us see. Some may say C depending on A, because yesterday K we have got. We said depending on K. But here let us see whether it depends on A or not. What is the leader? 1. Some students they will write 0. There is confusion between determinant and rank. Some students, intelligent students, the so-called intelligent, 2 rows equal. Therefore, determinant is 0. Therefore, they will write 0. So, we are not asked to find delta. We are asked to find rank. You should be careful. So, this is leader of the first row. So, we have to make below zeros. How to make zeros here? This is second row. This total is nth row. Apply the operation for R2. R2 minus R1. For R3. R3 minus R1, etc. Rn minus R1. Then we get it as 1 a square a power n minus 1. Remaining all are zeros. Remaining all are zeros. Yes or no? R2 minus R1 0, R3 minus R1 0, Rn minus R1. So therefore, here when I told you whenever there is a variable a, k, divide into 2 cases. So a equal to 0, a not equal to 0. In both the cases, what is the rank? We have to test always whenever there is a variable, because there is an option given depends on a. So let us check. If a is 0, then this will become 1 0 0 0. Remaining all 0 rows. This is an n by n matrix. How many non-zero rows? How many non-zero?
One.
One.
Madam. One.
So rank first row. When A is 0, rank is 1. Suppose A is not 0. If A is not 0, then also this is non-zero row. Even if A is 0 also, it is non-zero row. If A is not 0 also, how many non-zero rows? This is the only non-zero row. In that case also, rank is 1. So whether A is 0 or not 0, rank is 1. So it does not depend on A. So rank of A is fixed for all A. Does not depend on A. For all A means when A 0 also same answer, not 0 also same answer. Therefore it is for all A. Therefore rank of A is 1. Option is 1. D option. Okay. Yesterday's question. Let us see. K, rank of this matrix. K, rank is option A 0, 1, 0 or 1. D
1.
So how do we
1,
find
madam.
out? Let us see.
C.
K, let us take. So apply the operation R2 minus R. So
C.
2 cases arises. I told you whenever there is a variable, divide into cases. When K is 0, A becomes null matrix.
Option C, ma'am.
Option C.
Zero.
So this is 0. What is the rank of A? 0. Because if K is 0, rank is 0. Rank of null matrix. K is not 0. Then this is the leader. We have to make below zeros. This is R2. This is R3. Total row. This is R1. So K minus K 0, K minus K 0. Apply the operation R2 minus R1. For R3, apply the operation R3 minus R1.
Right.
Then it reduces to K, K, K,
0,
0,
0.
0, 0, 0, 0. So K is not 0, where K is not 0. So how many non-zero rows? One non-zero row. Because K is not 0, this is a non-zero row, 2 0 rows. So what is the rank of A? Number of non-zero rows, which is 1. So if K is 0, answer is 0. K not 0, it is 1. So it is depending on K. What is the rank? Either 0 or 1, depending on K. So depends on K is correct, 0 or 1 is correct. So depends on K. Two options, two answers for this. Depends on K correct, because whenever K is changing, your rank is changing. So rank of A is 0 or 1. C option is the correct option. So like this, yesterday's questions also can be done very easily using Echelon. Okay. Any doubts in finding rank? Emma, any doubt? Yeah.
No.
Definition లో ఫస్ట్ పాయింట్ 0 rows if any should be at the bottom of the matrix.
Correct.
అయితే మనము ఫస్ట్ ప్రాబ్లం చేసినప్పుడు బాటమ్ రో 0 మొత్తం అవ్వలేదు కదా మ్యామ్, లాస్ట్ 1 ఎలిమెంట్ ఉంది కదా
ఎక్కడ
ఫస్ట్ ప్రాబ్లం.
అయితేనే ఉంటేనే if
Already అవుతలే.
if at all it is there, if there is a 0 row, I have 0 rows. 0 row if any,
Yes,
this
yes.
word is any. If there is any, it should be at the bottom. If it is not there, very happy.
Okay.
This rule doesn't, this rule is not applicable.
Okay, ma'am.
If there is only. Okay.
Okay. Okay, ma'am.
Right.
Thank you.
Next, any doubts up to this? Shall I proceed?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So we have now some questions based on this. So before going to them, let us have the linear system. I want to see what is the application of this rank of the matrix. Then we'll go for previous papers questions. Yesterday we did not do all because they come under a number of solutions, linear system. So let us do first linear system, then we'll go for previous papers questions. So definitely you are getting one question. So here what is meant by a linear equation? This is the base input of linear algebra. What is meant by linear equation? So generally we will be saying an equation of degree 1 is what is called as linear equation. So in your 7th class, and I think so, there you had only one variable. So linear equation means equation of degree 1 is what is called as linear equation. You studied. They are also called simple equations. But now we are going to study linear equations in not only one variable, many variables. Then how are we going to define a linear equation? Is any equation which is reducible to the form, any equation reducible to the form A1x1, A11x1 or A2x2, ANxn is equal to B1. Here A1 to AN, they are constants. B is also constant. X1, X2, Xn are unknowns. That is, what is the degree of each unknown? X1 power 1, X2 power 1, Xn power 1. That is degree of each and every term. Degree of each and every term in the equation is 1. Then such an equation is what is called as linear equation of this particular form is called linear equation. Then, for example, which of the following are linear? Which of the following are linear equations? I'll give you some questions. First one, 2x1 plus 3x2 is equal to x3 square. B option. 3x1 minus x2 is equal to x1 x2. This is 3x plus 4y plus 5z is equal to xy. 3x is equal to 6 minus 2y plus 3z. Can you tell me which are linear, which are not linear?
D is linear, ma'am.
Only option D is linear.
So, some are saying B is linear. Some are saying D is linear. Tell me. Any more answers? Which are linear?
D only, madam.
D. Option D, ma'am.
Option D only. Some are saying B also. First one definitely.
Option D.
Why first one is not linear? Because x3 square. The degree of x1 is 1, x2 is 1, but x3 is also a variable. If you get it left side, minus x3 square equal to 0. So the degree of x3 is 2. If any variable, any one of the variable is of degree more than 1, then it is not linear. Here, why it is not linear? Some students, they argue x1 power 1, x2 power 1. Here also x1 power 1, x2 power 1. Degree of each and every term is 1. Why it, every variable is 1. Then why it is not linear? I said.
Powers we added.
So I said degree of each and every term. You might have observed that I used the word term. So what is the degree of this term? 1, because x1 power is 1. This 1. What is the degree of this? This is called as a monomial. For a monomial, degree means sum of the powers. Here 1, here 1. So what is the degree of this term is 2. So this is not a linear equation. Non-linear. Not a linear equation. Even though degree of x1 power 1, x2 power 1, but it is in form of product, monomial. So degree is sum of the powers, that is 2. Here again. Same story. X power 1, y power 1, z power 1, but this is a monomial. What is the degree of this is 3. 1 plus 1 plus 1. So it is also not a linear equation. Next here. Degree is 1, degree is 1, degree is 1. And you can also reduce it to the form, standard form. Get all variables left side, constant on the right side. This is a linear equation. Okay. So we understood what is linear equation. Once you have linear equation, we define what is called linear system. What is meant by linear system is collection of linear equations. That is collection of one or more equations is called linear system. One or more linear equations is called linear system. Every equation should be linear. For example, sometimes a linear equation may contain only one equation. This is also a linear system. It's a linear system containing only one equation. It may contain one or more than one. Linear, you can call it linear equation, or you can also call it as a linear system containing one equation. Only one equation. Next we see system of linear equations. You can have more than one also. So these two are two equations. This is what is called linear system. This is one equation, this another equation. Together is called linear system. That is two linear equations, more than one. So you can have any number. You can have one equation, two equations, three equations, and so on. So the system of equations, that is a system containing one or more linear equations, the collection of linear equations is called as linear system. Next question comes, what is the solution for the linear equation? What is meant by solution for linear system? So a linear system will be containing variables and constants. Here variables are the x, y, z. So what is meant by solution is, for the linear system, the values of unknowns x1, x2, xn, which satisfies the linear system, that is every equation in the linear system, is called solution. Which will satisfy each and every equation. That is, the values, when you give, if it satisfies all the equations, then it is what is called a solution. It is denoted by, generally, don't take x1 one solution, x2 one solution, like that. Together, this is called a solution. Not x1 one solution, x2 one solution, like that. Together, the column together is called solution for linear system. For example, number of solutions. The number of solutions for number 1, x minus y is equal to 4, then 2x plus y is equal to 2. Number 2, x plus x minus y is 4, 2x minus 2y is 4, 3x minus 3y is equal to 5. Number 3, x minus y is equal to 4, 2x minus 2y is equal to 8. Here I will take 3x minus 3y is equal to 12. Let us see. Solutions we want to find. So what is meant by solution? The values of x and y which will satisfy both the equations is called as a solution. So when you take first one, x minus y is 4, 2x plus y is equal to 2. Then how to solve? This is like your 8th class problem. They are called simultaneous equations. Two linear equations only. More than two, we cannot call simultaneous. These are two simultaneous equations. So how do your teacher taught? Add them. Then you will get 3x is equal to 6, x equal to 2. Substitute in any one of the equations your teacher told in 8th class, and you got this answer as minus. So what is the solution for this system is, number of solutions are, means don't write 2. X equal to 2 one solution, y equal to minus 2 equal to solution. You should not say number of solutions are. So solution means x and y put together. This is called a solution. How many solutions? Unique solution. We are getting only one set of x and y satisfying. So number of solutions are, how many solutions? Only one solution. This is the only solution. You should not call the two solutions. X and y together is called solution. How many solutions? Only one solution. Unique solution. So how many? Only one. So we denote this graphically. Sometimes you may be given graphs. Graphically, this unique solution is represented like this. This is a straight line. Is it not? Then this is also a straight line. Here x is positive, y is negative. So x positive, y negative comes here in this. X is 2, y is minus 2. Again, 2x plus y is equal to 2. This equation also intersects this. This is one equation, this is one equation. Because y equation, it is in the form ax plus by plus c equal to 0. Anything in the form ax plus by equal to 0 is called straight line. This is a straight line. Ax plus by plus c 0. Ax plus by plus c 0. So graphically, this represents one straight line. This represents another straight line. Both are intersecting at this particular point, 2 comma minus 2. So indirectly, what is meant by solution is
Ma'am, graph show with the numbers, ma'am. I mean, give numbers and show the graph. It is confused.
You can do it, no? Yes, teacher. X minus 4. Otherwise, I will not draw the axis. This is the one. Okay. Takes time. Waste of time. This is one straight line. This is another straight line. Both are intersecting at this particular point. You know how to draw straight lines using your 8th class model. Give some values for x-axis, y-axis. You draw after going to your place. Waste of time. Is it not? So this is 2. Give values for x. Give values for y. X-axis, y-axis, 8th class model. So you will get, what I want to say is this is one straight line. This is one straight line. They're straight lines. They're intersecting at some point. So this point of intersection is called solution. So what is the relation between matrix theory and coordinate geometry then? How it is linked? This is called solution for linear system. And in coordinate geometry, the solution is what is called as the point of intersection of straight lines. So each equation is a straight line geometrically. The point of intersection of the straight lines given by them is the solution. They are intersecting in how many points? Only one point. So number of solutions equal to 1. So what is meant by solution for 2 equations means here the point of intersection. If we take second equation, 2x minus 2y 4, 2x minus 2y 4, 3x minus 3y is 5. These are the equations. So if we try to solve this equation, first equation is giving you x minus y is equal to 2. Second, this equation is 5 by 3. So when 1 and 2 implies 2 equal to 5 by 3, which is an absurdity. 2 cannot be equal to 5 by 3, which is wrong, incorrect. That means there exists no x and y which will satisfy both the equations. Because if this equation is satisfied, this will not be satisfied. Absurdity means there exists no x and y which will satisfy both. Because 2 cannot be equal to 5 by 3. For no values of x and y, 2, if it is satisfying first, it cannot satisfy second. There are no x and y which will satisfy both. Because you are getting an absurdity. So there exists no x and y which will satisfy both. For example, if I take x equal to 4, y equal to 2, first equation is satisfied, 4 minus 2 equal to 2. 2 equal to 2 satisfied. But this equation becomes 2. 2 equal to 5 by 3 is not satisfied. Because LHS is not equal to RHS. It is an absurdity. Therefore, here there exists no x and y which will satisfy the system. That means there exists no solution. Because there exists no x and y which will satisfy both. If this is satisfied, this will not be satisfied. If you subtract according to your teacher model, your 8th class teacher asked you to subtract, you'll get 0x plus 0y. 2 minus 5 by 3 is 1 by 3. Is there any x and y which will satisfy this equation? Left side of the equation is always 0. 0 into anything, 0, 0 into left side is always 0. Right side is not 0. Therefore, there exists no x and y which will satisfy both the equations. Hence, there exists no x and y satisfying means no solution. How do we represent no solution case? That means no common point at all, no point of intersection. No point of intersection. That means this is one line, this another line, no common point. So they are non-intersecting lines. No solution means They are parallel lines. You can see two lines are parallel if and only if they differ by constant. Here you can see these two are two parallel lines. The difference is only in the constant. X and Y coefficients are same. So they are parallel lines. So parallel lines, therefore, no solution, no common intersection point. The point of intersection is called solution. There is no common point. Therefore, no solution. This is no solution case graphically. Third case is, third problem, you are given 2x minus 2y is 4. Third problem. 3x minus 3y is 12. 2x minus 2y is 8. So if you simplify this, it means x minus y is 4. Here also x minus y is 4. Both are giving rise to only one equation. Only one equation. Only in appearance there is difference, but otherwise they are one and the same. So if you take x minus y 4, x minus y 4, then what is the solution? So according to your 8th class teacher model, subtract them. So 0x plus 0y is equal to 0. What are x and y which will satisfy this equation? What are the values of x and y which will satisfy this equation? 0 into any value.
Infinite.
0 into any
Infinite.
value of x is always 0.
Many numbers.
Many. 0 into y is 0. So you are getting 0. RHS is also 0. For all x and y, whatever may be your x and y, it's always 0 equal to 0. 0 into x 0, 0 into y 0, 0 plus 0, 0. 0 equal to 0. That means satisfied for all x comma y. Therefore, every x comma y, any real number will satisfy this. X minus 5, 4, x minus 5, 4. So there are many, how many solutions? Infinitely many. How will you get those infinitely many? How to solve this equation? Write one in terms of the other. One equation, whenever equations are less, variables are more, automatically you will get many solutions. How to get many solutions? Write one in terms of the other. Then what are the values of x? X is real. You can give for x any value that will give you y. If x is 0, y is minus 4. So what is the solution? 0 minus 4. X is 1, y is minus 3. This is also a solution. X is 2, y is minus 2. This is also a solution. Like this, there are infinitely many solutions. How many solutions? Many solutions. What is the set? Solution set. Solution set means set of all solutions is called solution set. So set of all x, y. X is free variable, y is x minus. X is real or it is free. Such variable x is called free variable. What is meant by free? You can give any value for that. Such a variable is called free variable. How to get infinitely many solutions? Like this. If you give x equal to 0, you will get 0 comma minus 4. X equal to 1, 1 minus 4 is minus 3. Like that, how many solutions you get is infinitely many solutions you get. Okay. Now, this is the solution set. For this, what is the solution set? No solutions. So what is the solution set? Set of all possible solutions. No solution at all. That means empty set.
Right.
Empty. Here, how many solutions? One solution. So what is the solution set for this? What is the solution set? X
2
equal to
minus 2. 2
2
minus 2.
minus 2
Minus 2.
minus
2.
2 na 3 na
2 ne.
2 minus. So this is the solutions. Solution means 2 minus 2. Solution set means write in the set builder. So in the first case, we got only one solution. Second case, we got no solutions. Third case, we got many solutions. So how many types of solutions are there? What is meant by solution? The set of the values the variables takes and satisfying the equations, each and every equation in the linear system is called a solution. set of all possible solutions is called a solution set. But we want to find out this is the solution set. So after solving, you came to know that there are three types of solutions. Our aim is, without putting pen on the paper, by looking at that, or at least with a few steps, can we say how many solutions without solving? Without solving like this, because only two equations, two unknowns, we are able to solve. Suppose you are given 100 equations with some 20 unknowns, then how many solutions it will have? We want to find out, is there any solution or not, first of all. So those solutions, those things we are going to study now using a rank concept. So using rank concept for the higher degree, here it are very simple equations. If suppose 3 equations are given, 4 unknowns are given. In your intermediate, you studied only 3 equations, 3 unknowns. Your 10th class, 2 equations, 2 unknowns. You never studied more equations, less equations, more unknowns, or more equations, less unknowns. Extremes you have not studied. Number of equations always equal to number of unknowns. That's what you have studied earlier. Using Cramer's rule, matrix inversion, Gauss-Jordan, you found solutions in your intermediate. So there are only 3 by 3, 3 equations, 3 unknowns. But now, suppose 2 equations are given, 3 unknowns are given. We don't know how to solve using Gauss-Jordan or Cramer's rule or matrix inversion. They are applicable only when you are given 3 equations, 3 unknowns. But in other extreme cases, we cannot solve using those rules. Then how to solve them, that we are going to see now. Okay. So what are the types of solutions? There are 3 types of solutions. Solutions are of how many types? 3 types. One is unique solution.
Unique solution.
Second one is no solution. Third one is many solutions. Solutions are of 3 types: unique solution, no solution, many solution. So let us see how to identify. So linear system, we want to solve higher order. This is only 2 equations, 2 unknowns, higher equations. So linear system, our aim is now to solve linear system in m equations, n unknowns. This is our aim. N unknowns is given by A11x1, A11x1, A12x2, A1nx, A21x1, A22x2, A2nx, AM1x1, AM2x2, AMnx, BM. This is the system in M equations, n unknowns. What are unknowns? X1, X2, Xn. What are A11, A12, A1n? All are constants. So this is called linear system. This we want to write in the matrix form. Such a form is called matrix equation form. Matrix equation form, how to reduce it? We write the coefficients. Above system, we will try to rewrite in the form Ax equal to B. Into So this is in which form? Ax equal to b. This is called matrix equation. So linear system, we have reduced it to matrix equation form, because when you multiply and simplify, you will get back above. You can see how will you multiply? First row, first column. A11 x1 plus A12 x2 plus A1n xn. Second row, A21 x1 plus A22 x2 A2n xn. Mth, AM1 x1 plus AM2 x2 AMn xn. Equate them. A11 x1 plus A12 x2 plus and so on A1n xn is equal to B1. A21 x1 plus A22 x2 plus A2n xn is equal to B2. So if you multiply and simplify, you'll get back the above form. Above form is called linear system. This is called matrix equation form. So A is what is called as the coefficient matrix, Aij m by n, and X is what is called as an unknown matrix, x1, x2, xn, and B is what is called as the constant matrix, B1, B2, Bm. This is called constant matrix. This is m by n. This is coefficient matrix. This is variable matrix. This is constant matrix, Ax equal to b. So if we can get set of values x1 to xn, which will satisfy this equation. If this equation is satisfied, automatically all the equations will be satisfied, because the equation is nothing but inside is this only. So if x satisfies Ax equal to b, automatically that x will satisfy each and every equation. That is what is called solution. So this is called as variable matrix. If you find values, whatever you get, that is called solution. What is meant by solution? Which satisfies this matrix equation form, or in turn, the set of values which satisfies each and every system. That is what is called as the solution. Now, there are two types. The question is how to solve for x. We want to solve for x. So, in order to solve, you should know the nature. So, there are two types of systems. B is 0, then Ax equal to 0 is called homogeneous system. The linear system is said to be homogeneous if right side is 0, Ax equal to 0. That means A11 x1 plus A12 x2 and so on up to A1n xn is equal to 0. A21 x1 plus A22 x2 A2n xn is 0. That is, everything on the right side is 0. Left side no constants. Then such a system is called homogeneous system. If B is not 0, what is meant by B right side? That is at least one of B1, B2, Bn, one of B1, B2, Bm, at least one of them is not 0, then it is what is called as non-homogeneous system. Non-homogeneous. Homogeneous system, non-homogeneous system. We want to find out solutions, sometimes without solving, sometimes with few steps. So here Ax equal to 0, how we solve this? There are two types of solutions we get. This, if there is a solution, such a system is said to be consistent. What is the consistency? There is a solution. No solution means inconsistent. There is solution means at least one solution, exactly one, unique solution, many solutions. Both of them comes under that is consistent system. No solution case comes under inconsistency. Inconsistency means no solution. Homogeneous system. This homogeneous system will have two types of solutions. So, for a homogeneous system, what is our observation is, for example, what is the example of homogeneous system is, this is a homogeneous system in two unknowns. Or you can also have like this. So two types. This is also homogeneous. This is also homogeneous. Here, if you put what are the values of x and y which will satisfy both, that is called solution. In this case, if you x equal to 0, y equal to 0, if you take x equal to 0, y equal to 0, if you substitute, 0 plus 0 is 0, 0 equal to 0. 0 minus 0 is 0, 0 equal to 0. So 0 solution is that is x equal to 0, y equal to 0. is satisfying. That is 0, 0 is the solution. Here also, if you put x0, y0, z0, 0 plus 0 plus 0, 0, 0 minus 0 plus 0, 0. So x is 0, y is 0, z is 0 is a solution. Here also this is a solution. The question is this the only solution for this? Or are there any x and y which will satisfy? Is 0 solution the only solution? Or is there any other solution also apart from 0 solution? For homogeneous system, 0 solution is always a solution. Because if you put variable 0, automatically it will be satisfied. So 0 solution is always a solution for the homogeneous system. Question is that the only solution, or is the system having some other solutions also apart from 0 solution? These are the two things which we have to discuss. When you look at this, how will you solve using your 8th class method? X minus by 0. Add them according to your teacher methodology, 8th class teacher method. X is 0. Substitute in any one of the equations. Y is also 0. X equal to 0, y equal to 0. So 0, 0. This is the only solution. You cannot get any other solution apart from the zeros. Because when you are solving, you are getting 0, 0 only. So 0, 0 is the only solution. That is 0 solution is the only solution. For this also 0 solution is there. But is there any other solution also? We want to know. Answer is not only 0 solution, the system is having many solutions. How? For example, if I add these two, I get 2x plus 2z as 0. X plus z is 0. X equal to minus z. If I substitute here x equal to minus z plus y plus z is 0. So y is 0. Y is 0, but x equal to minus z. So what is the solution set is x, y, z. X is minus z, y is 0, z. So how many solutions are there? Infinitely many, because z is a free variable. You can give any value for z. If I put z0, I will get 0 solution. But this is not the only solution. If I take z equal to 1, I will get the solution as minus 1, 0, 1. I can have even z equal to 2, minus 2, 0, 2. This is also a solution. Like this, you can keep on substituting values for z, then you will get solutions. How many real numbers are there? Infinitely many. So how many solutions you get? Infinitely many solutions you get. So this among infinitely many, 0 solution is also there. Non-zero solution is also there. That means if 0 solution is the only solution, one case. Not only 0 solution, 0 and non-zero, all are solutions. Then it comes under many solutions. Among many, 0 is also there. So for a homogeneous system, there will be two types of solutions. Only 0 solution, that is unique solution. Only one solution, namely 0 solution. And only 0 solution, unique solution. Another name for this is trivial solution. What's meant by trivial? 0 solution. When are you going to get that is, if determinant of A is not 0, or in other words, rank of A is equal to n, rank of A is equal to n, because if A is rectangle, then you cannot find determinant. If A is square matrix, then you can find determinant. Determinant not 0. If it is square matrix, if it is rectangle, rank of A should be equal to n. N denotes number of columns. How to find rank we have seen. If it is equal to number of columns, then the system will have only one solution, namely 0 solution or trivial solution. If the determinant is 0 or rank of A is less than n, then the system will have many solutions, infinitely many solutions. Not only that, it is also called non-trivial solution. Non-trivial solution exists. That is, non-zero solution exists. Zero is also there, non-zero is also there. Zero solution is there, non-zero solution. There are infinitely many solutions for the system. So, two cases, determinant not zero, rank of A equal to 1, only zero solution. Determinant 0, rank of A less than and many solutions. Non-trivial solutions or non-zero solutions. Okay, these are the two cases. Next one is non-homogeneous system. So, for example, this let us study. So, without doing, we want to know how many solutions. After solving like this, we want to know without solving. So, this concept you have to use. If the determinant is not 0 or rank of A is equal to n, in any case, system will have how many solutions? Only one. Without solving, you can know. Here also, if rank is less than n or determinant is 0, the system will have many solutions. Why two concepts is, if it is square matrix only, you can go for determinant. If it is rectangle, you cannot go for determinant, then you should solve using this rank concept. For example, as we said here, x plus y plus z 0, x minus y plus 0. Let us apply. So for the questions which we have solved, x plus y 0, x minus y 0. We got 0 solution as the only solution. Now using the concept. So you can write matrix equation form, xy. After solving, we came to know. Without solving, we want to know. This is your A. Then what is the determinant of A is 1, 1, 1 minus 1. If the determinant is not 0, how many solutions? Only one solution, 0 solution. E is the only solution. So x equal to 0, y equal to 0, E is the only solution. How many solutions? One solution, unique solution. So what is that? Trivial solution. What is that solution? X equal to 0, y equal to 0. Without solving, like your 8th class method, we could predict using this concept. Earlier, after doing, also we got the same answer using our 8th class model. So without solving, we can know using determinant concept. Okay. And earlier, here, one equations, x plus y plus z equal to 0, x minus y plus z equal to 0. Let us solve that. X plus y plus z 0, x minus y plus z 0. Write this in the form 1, 1, 1, 1 minus 1, 1. X, y, z. 0, 0. This is in the form Ax equal to 0. What is the order of the matrix? Is 2 by 3. N is 3. Find rank of A. How to find rank of A? Here we cannot find determinant because it is rectangle. So we have to go for echelon form. This is the leader, below that 0. So R2 minus R1. 1, 1, 1. 0 minus 2, 0. This is in echelon form. This is leader, below that 0. This is leader, below that nothing to make 0. This is in echelon. So what is the rank of the matrix in this case is, how many non-zero rows? 2. What is n? 3. Rank is less than n. Therefore, system has many solutions. This is how we try to predict using this concept. Is it clear now? So, by looking, one more thing, one more hint I will give you. Even this much you need not do in the exam. For the homogeneous system, if equations are less, unknowns are more, automatically such a system will have many solutions. This is only for homogeneous. I'm repeating once again. Unknowns how many? 3. Equations how many? 2. If more unknowns are there, less equations are there, if it is homogeneous, without putting pen on the paper, you can answer. How many solutions means infinitely. You need not even solve. Because unknowns are more, equations are less, and it is homogeneous system, that will have many solutions. Even you need not find out rank and all, directly will get the answer. I'll give that as a shortcut formula. A homogeneous system in which number of equations, number of unknowns more than number of equations. More than number of equations. Is called homogeneous. Gives many solutions. So without solving, you can infinitely many solutions. A homogeneous system will have if number of unknowns are more and equations are less. That is, m is less than n. N denotes number of unknowns, m denotes number of equations. That is, if A is an m by n matrix, m is less than n. If it is more than n, we cannot say. If it is more than n, we cannot say. If it is less than n, definitely it will have many solutions. If it is equal to n, it may have one solution or many solutions. We don't know. We have to do it. But if it is less than n, definitely the system will have many solutions. So for example, we are having x plus y plus z plus w0, 2x minus y plus z0, y equal to 2z. Then number of solutions are
Many solutions.
many. Without doing, can answer. Why is it so? How many unknowns? X, Y, Z,
4
W.
unknowns.
4 unknowns.
Four
How many
unknowns.
equations?
3
3.
equations.
So when number of equations are more, it is homogeneous. Moreover, homogeneous means even if you take on the left side, it will be 0. No constants, no non-zero constants. So without putting pen on the paper, you can answer number of solutions are many. This you like. So you want questions like this in your entrance. So given any question, system, first to see how many are there. Is it homogeneous or not? If it is homogeneous, unknowns more, equations less, definitely many solutions. If it is equal, we cannot say. If it is more, m is more than n, we cannot say. We cannot say. But if it is less, definitely for homogeneous. This is one type. Okay. Now up to this, any doubts? First you tell me, then I'll go for non-homogeneous. I'll solve many questions given in previous papers. They're very interesting. So at present, basic concepts you should understand to answer your previous papers questions. Now, any doubts?
No, ma'am.
No.
No, no.
No. I'll solve one. If the equation kx plus 2y plus z is equal to 0, x minus 3y plus 4z equal to 0, and this is 2x plus 3y minus k equal to 0. Then, if the system has many solutions, then values of k are and number of real values of Kr. Number of real Kr. Real Kr. Let us see. Then values of Kr dash, number of real value, real Kr, number of distinct Kr, distinct values of number of real Kr, number of values of Kr. What are the values? Number of real K, number of distinct values of. Let us. The system is having many solutions. When it will have many solutions, provided many solutions means go back. Many
That is
solutions
zero.
means, so determinant is 0. Many solutions. Yeah. System will have many solutions only when det A is 0, rank of A is less than. Det is 0. So it means we have to reduce it to which form? Ax, that is matrix equation form. The coefficient one is K 2 1, K 2 1, 1 minus 3 4, 2 3 minus K into x y.
K value is 3, ma'am.
So let us. So this is Ax equal to 0. So many solutions implies, in the exam you need not write all these steps because I have to explain I am doing. Many solutions implies det A is 0. Directly from here you take det A. That is all coefficients. You consider equate to 0 determinant. So determinant K 2 1, 1 minus 3 4, 2 3 minus is equal to 0. Plus minus plus. So K into minus 3 minus 3 4, 3 minus 2 into 1 4, 2 minus plus 1 into, close the row and column, 1 minus 3, 2 3 is equal to 0. So K into, what will you get? K into 3K minus 12 minus 2 into minus K minus 8 plus 1 into 3 plus 6 is equal to 0. 3K. Three K square plus 25C. Am I right? There is any mistake, tell me now itself. So
No.
this, how many values of K means? Number of values of K are. Without solving, you can answer. This is
2.
second degree equation. So how many K values you will have?
2.
A second degree equation will have 2. How many values of K? 2 values. But what are they? How many real? That if you want, you will have to solve it. Solving can be done using factorization or minus b plus r minus. So plus or minus b square minus 4ac. 4 into 2500, that is 300 by 2a. So 100 plus r 10 plus r minus 200. 10 plus r minus root minus means I. Root 100 is 10. Root 200. That is 10 root 2 I by 6. So how many real K? K are values of K are this. These are values of K. How many values means 2. Number of real values. Number of real values of K are. That is real solutions.
0.
Number of real solutions. How many? There is no real at all. They are all complex numbers. So this is 0. How many real solutions? No real solution at all. How many values are there? 2 values. They are complex. So number of real values of K are, or number of real solutions are 0. There is no real solution at all. 2 solutions are there, but both of them are complex numbers. So number of real values of K are, or number of real solutions are 0. This is how questions may be given in the exam. Any doubts? Is the concept clear? So you may be given a question like this. What is the application? You have understood the concept. So without doing, you can answer how many solutions. Sometimes question may be given like this. If this system has many solutions, then the values of K are, number of real values of K are like this. Number of distinct values of K are. How many distinct values? 2. Both of them are distinct only. How many distinct values of K? 2. One is with plus I root 2, another is with a minus I. So how many real? No real at all. Okay. Next. Any doubt? Any doubt, ma? Shall I proceed? Shall I times? Times you may get K as 2, 2 for example. Then suppose then number of values of K are 2. Number of distinct values of K are
1.
1, ma'am.
1. This is the depth. Number of real values of K 2, 2. But both equal to only 1. Distinct values means only 1. Real values means 2. Number of values are 2. What are 2? 2, 2. Repeating 2 times. Okay. Whenever the word distinct is used, you count only once. Okay. Now, let us go for non-homogeneous system. Non-homogeneous system, Ax equal to B, where B is not 0. This is called non-homogeneous system. This is the concept with this. Then 2 cases. If determinant of A is not 0, A is square matrix, or rank of A is equal to n denote number of columns of A, then system has unique solution. Unique solution. That unique solution need not be 0 solution. If determinant is 0, 2 cases arise. Earlier for homogeneous, many solutions, but for non-homogeneous, you should not conclude. It may be either many solutions or it may be no solution. 2 extreme cases are given by this. Det A 0, many solutions, or no solution. So if the det is equal to 0, then the system will have many solutions, or it is having no solution at all. 2 subcases. How to resolve then? How will we know to break this tie? Suppose you are given, there is no solution for the system. What is the value of k? Then det A is 0. Suppose you are given system is having many solutions, then also det A is 0. Using this concept, you can find k values as we have done earlier. If the rank is equal to n, determinant not 0, system is having unique solution. Unique solution means det not 0, rank of A equal to n. N denotes number of columns of A. Then how to break this? How will we know many or no solution? That you can break using this concept. Rank of augmented, take A along with B, formulate this. This matrix is called augmented matrix. Augmented matrix. Reduce it echelon form. If rank of augmented matrix is equal to rank of A, then system is consistent. Consistent means it may have one solution or many. Then subcases. Rank of augmented is equal to rank of A is equal to n. N denotes number of columns of A. System will have. System is consistent. System is consistent and has unique solution. And if rank of augmented is equal to rank of A less than n, then system is system is having many solutions. It is consistent only in this case also, but it will have many solutions. If suppose they are not equal, case 2, rank of augmented is not equal to rank A, then the system is inconsistent. How to find rank? We have seen already. Inconsistent. Inconsistency means no solution. Okay. So these are the cases. Rank of augmented is equal to rank of A, less than n, many, equal to n, unique, not equal, no solution. So this no solution case will not arise for homogeneous, because homogeneous is always consistent only. It is always having one ready-made solution, namely zero solution. Zero solution is always an available solution for homogeneous. Then why we are solving? We want to know whether that is the only solution or is there any solution also for that. For that investigation we are doing. Okay. So only in this case you have no solution case. So sometimes question may be given. If it is given as no solution also, det 0. Unique solution, sorry, no, many solutions also, det is 0. Det is 0 means either many solution or no solution. How to resolve? Using rank concept. Unique solution means determinant is not 0, rank equal to n. So let us do some questions based on this. First I will solve basic questions. Then we'll go for previous paper questions. Okay. So number of solutions. So number of solutions. Question. Number of solutions for number 1. I'll solve first general systems, then I will go for previous papers questions. As I said, how many solutions means generally students, if they memorize without understanding, they will write many solutions. Why they write many solutions? I told 2 equations, 3 unknowns. Unknowns more, equations less. Therefore, many solutions. Intelligent students will write, which is not correct. Where did I say that? Shortcut. Only for homogeneous system. That is not valid for Non-homogeneous. A homogeneous system in which a number of unknowns more than number of equations gives many solutions. This is valid only for homogeneous. For non-homogeneous, that may or may not be valid. May be valid, but not necessarily. Next. Only one I will do. Then you can have more on. Let us see. There is difference. I think you might have observed here. Here I will take 3 by 3. Suppose you are given this. I want to know how many solutions are there. Let us see. First case. X plus y plus z. Just I will show you the methodology. Then we'll go for previous papers questions. First question is x plus y plus z is 2. X plus y plus z is 2. 2x minus y plus z is equal to 1. The question. Now, let us write this in the matrix equation form. This is in the form Ax equal to b. X means x, y, z. How many columns? That is very important. N is 3. N denotes number of columns or number of unknowns. Always remember, number of columns will be equal to number of unknowns. That will be always satisfied. That value is called N. What is the methodology? This is in the form Ax equal to b. So we have to consider A along with b. Augmented matrix. 1, 1, 1, 1, 1, 2. 2 minus 1, 1, 1. This is leader. We have to make below 0. So apply the operation. R2 minus 2R. 2R. So minus 2R. R2 minus 2R. So minus 2, minus 2, minus 2, minus. So rough work. R2 minus 2R1, 0. Minus 1 minus 2 minus 3. 1 minus 2 minus 1. 1 minus 4 minus 3. This is leader. Below that 0. This is leader. Below that nothing to make 0. This is what is called augmented matrix. What is this called? Augmented matrix. A along with B. Some textbooks they use column. One they can use separate column. This is your A. This is your B. So A is equivalent to 1, 1, 1, 0, minus 3, minus. So what is rank of A is? How many non-zero rows?
2, ma'am.
2.
2.
Yeah. Rank of augmented?
Rank of AB also 2.
2. How many non-zero rows? Include B. For this also, this is in echelon form. Why did we stop? Is in echelon. Until we get echelon form, we have to continue our journey. This is also 2. N is how many? What is the value of N?
3, ma'am.
How many unknowns? 3.
3 number
So
of
by looking at this, you can see rank of augmented is equal to rank of A is equal to less than N. Therefore, what is the case? System is having how many solutions?
Infinite.
Infinitely many. So sometimes, when in this case, non-homogeneous system, sometimes if equations are lesser, unknowns are more, you may get no solution case also. So you should be careful. Merely by looking at that, don't conclude. Sometimes you may get no solution case in that case. So you should be careful. 2x minus y plus z equal to 3. 2x minus y plus z equal to 3. This is nothing but 2 minus 1, 1. X, y, z. 3. So A along with augmented. 2 minus 1, 1, 3. This is already in echelon form. This leader, below that nothing to make zero. So rank of augmented. How many non-zero rows? How many non-zero rows?
1.
1.
1, ma'am.
Rank of A is also 1. A means exclude this, only this. N is 3. So the system is having how many solutions? Many solutions. So system has many solutions. Okay. Next. Third case. Here we are having how many unknowns? How many unknowns?
3.
3, ma'am.
4, 4.
4, ma'am.
4. Because x, y, z,
4.
w is also there. 4 are. So let us solve. Only 3 equations. So 2x plus y plus w is equal to, Sarita, can you see? 2x plus y plus w is equal to 1. Is equal to 1. What is the second equation?
X minus 2y plus z
X
equal
minus
to
2y.
plus z
Hmm.
equal to 2.
Next
And 2y minus w equal to 0.
is the question. Third one. So we have to formulate augmented methods. So 2, 1, 1, 1 minus 2, 1, 0, 2, 1, 0, 1.
మ్యామ్ జెడ్ రాయాలి కదా మ్యామ్.
అందుకని 0, 1. 1 minus 2, 1, 0.
0.
0,
0,
2,
2,
0,
0, minus 1.
Minus 1.
Minus 1.
into xy zw is equal to 1,
1,
2,
2, 0.
0. This is Ax equal to B. So this is which order matrix? 3 by 4. N is 4. So what we have to do? We have to consider the augmented matrix. Had right side been zeros, suppose 0, 0, then we would have concluded many solutions. Without putting pen on the paper, you can conclude many solutions. Had there been zeros here, zeros unte many solutions on cheppundalam without doing. But now it is non-zero. So it is non-homogeneous. So you need to do. Leader below that 0. Two R2 minus R. 2R2 minus R. Leader below that 0. 2R2 minus R1. 2R2 minus R1. 2R2 minus R. This is leader below that 0. Now this is leader. We have to make below zeros. How to make below zeros? Yes, don't use 1. You should use only previous pivot. Remember that. If you use this one, this will become 0, but this will become non-zero. So be careful. To make these two zeros, use this. To make this 0, use only preceding one. Don't use previous. So how to make 0 here? Apply the operation for R3. 5R3
R3 plus
plus
2R.
2R3. This will be equivalent to 2, 1, 0, 1, 1, 0 minus 5, 2 minus 1, 3, Here, 5R3, rough work. Rough work. What is 5R3? 5R3 will be 0, 10, 0, minus 5, 0. 5R3. 2R1. 2R2. 0, minus 10, 4, minus 2, 6. 0, 0, 4, minus 7, 6. 0, 0, 4, minus 7, 6. This is leader, below that 0, leader, below that 0. This is in echelon form. This is pivot. Echelon form. So, what is the rank? Rank of augmented. This is your A. This is B.
B.
What is the rank of augmented? How many non-zero rows? 3.
3.
And A is equivalent to exclude last column. That will give you A. Exclude last column. That will give you A. Exclude last column. So, how many? What is the rank of A?
3.
3, ma'am.
N is
4.
4.
so rank of augmented equal to rank of A less than N. So how many
Unique
solutions?
Unique solution.
Huh?
Many solutions.
Many,
Many, ma'am.
many,
No,
many.
many solutions.
Many will be writing unique solution. Many students will be writing unique solution, but it is many solution because variables are 4. Okay, so we'll close for today here. Tomorrow's class will take up previous paper questions based on these concepts. Not tomorrow, next class. Okay, thank you, sir. So I'll share the document. Please go through these concepts. Now, any doubts? For you, I'll give you a few minutes. Yes. Actually, Ashok.
Okay,
Ashok.
madam. Okay.
Okay.
Okay, thank you, madam.
Number of solutions on adagala. Number of solutions on adagaledu. Number of independent solutions are. In one of the papers, you can find this terminology. Number of independent solutions are. So, dash. Sometimes you'll be asked to find. Sometimes number of real solutions, sometimes number of independent solutions. Formula is N minus R.
N minus R. Okay.
N minus R. N is this number of columns. Number of columns of A. And R is the common rank. Rank of augmented is equal to rank of A. This common rank is denoted by R. Number of independent solutions are N minus R formula. They are also called number of free variables. Sometimes you'll be asked to find number of free variables are. So number of free variables formula is, what are free variables? For example, when one equation given, you are saying many solutions. How many solutions? You can write x in terms of y and z, or y you can write in terms of x and z, or z in terms of x and y, whatever it may be. Right side variables are called free variables. You can give values for y and z, you will get x. All the three together is one solution. Y is 0, z is 0. Then x equal to 2. 2, 0, 0 is a solution. If you put x equal to 1, y equal, z equal to 1. 2 minus 2, 0. So 0, 1, 1. This is a solution. So you can give any values for y and z. So they are what are called free variables. How many free variables? So number of free variables is equal to same formula. N minus R. Here also, what is N? How many unknowns? 3. Rank is also 1 for this. So 3 minus 1, 2. How many free variables? 2. Because this matrix is 1, 1, 1, 2. What is rank of augmented? 1. Rank of A? 1.
1.
N is 3. So N equal to 3. Rank is 1. So how many free variables? 2 free variables. What are they? They can be y and z. Somebody says, why are you writing like this? You can write like this. Yes. Then x and z are free. Or you can write z is equal to 2 minus x minus y. Then which are free variables? X and y. Free variables are your choice. They can be either y and z or x and z or x and y. But how many? Only 2. So number of free variables are 2. What are they? You are having freedom to choose the free variables. Okay, sometimes you may get bit based on this. Okay, good question.